Hello, this is Al Koritz. I'm the Service and Applications Manager at Electron Microscopy Sciences. I'd like to introduce you to the EMS 156 system that you purchased and give you a general overview of what's in the box and how it all goes together. The first thing I'll show you once you have it out on the tabletop is it's shipped with a restraining plate which keeps the arm firmly attached to the bell jar so it can be shipped without any damage to the bell jar. You need a Phillips screwdriver. You pull the silver knob at the front of the arm, raise it up, remove the foam damper. Then on the top of the plate there's two Phillips screws that you remove. Here's the restraining plate and the two Phillips head screws that hold everything in place. Okay, although it's very tempting to throw this in the trash and not keep it, if you ever need to return the instrument for service, this is the ideal way to button everything down so it ships with the minimal chances of being damaged. Okay, so once the restraining plate is removed, you can have access to the chamber. I do know there's a big hole up here right now, but we'll discuss that a little later. We can remove the bell jar and examine the chamber. This is the orifice where the turbo pump is installed. This is the gear motor box for the stage. This is a film thickness monitor, which your system may or may not have depending on configuration. One of the beauties of this system is that these areas are not recessed. It's easy to get to, easy to remove things. In the dark ages of coding systems, they used to be in some sort of recessed area where you had to be a contortionist to attach or remove them. It's very, very easy to get to with this system. I've turned the instrument around so you could see some important areas of concern while you're doing the installation. Mains power switch, power in. There's a special power cord for this unit. It comes with the system in the accessory pack. I'll discuss that at some later time. This is the power out that goes out to your rotary pump. So your rotary pump is switched on and off by the machine at the beginning and turned off at the end of the coding process. This is the only user able fuse in the system. It only services the rotary pump. So if your rotary pump isn't turning on and the rest of the system is, this would be the one to check. Over here we have an Ethernet cable connection, a Cat5. This is mostly for service people to interface, upgrade software, do some diagnostics. This is argon gas in for sputtering. This is nitrogen gas in for venting. This is the spigot out of the back of the machine which goes to the hose, which eventually ends up at your rotary pump, which we'll discuss a little later on. Whenever you call in with a question or such, it's important to provide us the serial number because then we can check our records and we know how the system happens to be configured. At the top of the box when you took the unit out of the shipping container, it contained two boxes. The box that has the narrow width is the accessory box, and we'll get to that next. But I want to turn our attention to the accessory box, which has all the materials to plug in the machine, get it hooked up to a rotary pump, and then we'll switch to the front of the machine. That's where the other box comes into play. This is an absolutely brand new machine that we use for demos. So this is essentially the way everything comes. I might add that we're not perfect, and the reason why I'm going over this is because if you can't find something, you at least know what to call it. This way you can contact us and we can send a replacement right away. So this is the power cord. It's a special power cord, as I mentioned before. The bureaucrats at the ISO standards place makes all these funny different cords. Rather than making one cord that works for everybody, they have to have many different types of ends on them. I can understand that this end varies from country to country. I have no concept of why this end needs to be changed. It's just a bureaucratic thing. Get over it. We deal with it here quite often. So this is the mains cord. It plugs into that port which I described earlier. These are carbon rods that you get with the system. The system takes 3mm diameter carbon rods. We'll talk about those a little later. Inside the bag, we do have a cheat sheet, a quick start guide, but we find that some people don't look at the quick start, and therefore we provide a video which will go over a great number of these details. This is the operator's manual. It's on a thumb drive in a lanyard. So if you're looking for an operating manual, it's an electronic copy on this thumb drive. This is the exhaust filter for the rotary pump and the adapter. This is the special wedge cutting tool to fashion a very special end on the carbon rod so you can do protocols like ramped carbon. These are the two carbon rod cutters. The blue is 1.4mm diameter spigot. The red is 1.2. We need thinner spigots so you get a more uniform evaporation of material. These are spacers for something called the dark space shield, which is involved with the sputter head, which we will talk about later. These are spacers so you can extend the height, so you can install thicker sputtering targets. Sputtering targets typically come in 0.1mm and 0.03mm thickness, but you can get them up to 1mm thick if you so desire. The 0.3 and the 1 require spacers. This is all in the manual, but I'm identifying them because some people lose them and throw them out and maybe need them later on down the road. This is the special power cord that we make up that powers the rotary pump. this particular end of the cord goes in here on the back of the system. This end is a very standard sort of modular plug that we see here in the US. This plugs into the rotary pump, and I'll show you how to connect that shortly. Okay, in this plastic bag are a number of small items. This is a filter that you can install in the nitrogen location if you're venting with room air without using nitrogen gas. This is a little T-piece that will allow you to vent your system with argon gas if you only have one gas tank. Venting with argon is better than venting with room air because it's a dry gas. And you have your supply line from the tank, and you cut 2 small pieces off the supply line and have one go off this way and one go off this way, and then you attach the other end to here, and then that plugs in here. You get the other one that plugs in here. Now you're venting with argon gas. Some of these smaller items that arrive in the accessory kit, there's 2 Allen keys, which are pretty much all that you need for setting up the different accessories which are in the other box. You have some spare springs for your carbon rod evaporators. You have a spare fuse, which is for the rotary pump, which goes there. And then you have vacuum clamps for attaching the oil mist filter and the vacuum line from the instrument to the rotary pump. More on those in a second. You have a pen stylus, which attaches and mounts on the side of the instrument. We're not going to do that. Then we have a vacuum line. The side with the hose clamp gets slid on the back of the spigot on the unit itself. Yes, it is a tight fit. No, you should not use any special lubricants to make it easy. You just have to sort of fight with it. Tighten it down as far as you can comfortably attach the clamp. This is a 16 kF vacuum fitting. That's the correct name for the size. It goes from 16 kF to a hose spigot. Some pumps that we provide have 25 kF. KF is just the nomenclature. 16 means that it's 16 millimeters diameter on the inside here. There's a 25 kF, which means that it's 25 millimeters. So it's easy to differentiate on the sizes. This goes to the intake of the rotary pump. Okay, this is the typical rotary pump that we supply for the system, except it doesn't say demo on it because this is one of our demo pumps that we use in our applications labs. I just wanted to show you this side. You should be provided a pump for the correct input power of the coating tool itself. The coating tools have a switching power supply, So you can feed them anything between 90 and 240 volts and they will be perfectly happy. However, the output to the rotary pump via this power cord is the same as line voltage. So you have to make sure that your rotary pump is compatible with the line voltage of the system. So this is 115 volts. So we have 115 volts going out of the machine. So this is set to 115. You can put a little screwdriver in there and switch it to 220 if necessary. But check that first. 2, there's an on-off switch here, in and out, O and I. So this is turned on. So when the coating tool is started with a process, the rotary pump will automatically turn on. Now let's look around the front of the pump. The pump comes to you with caps over the inlet and the outlet. Please note there's an arrow pointing towards the inlet. That means gas is going into the pump here. And there's an arrow pointing away, which means the gas is going out here. That's your exhaust system. This is for a oil retrieval system, which is not supplied with your pump and is really not necessary. So to fill it, you just stick a screwdriver in here, or the newer pumps have a different arrangement with a hex head that can go in there. You open this up, you open up your oil, you pour oil in. The oil should end up between these two marks. I usually put it about 2/3 up, or half to 2/3. Once the oil gets hot after the pump is run for a while, this oil will expand a little bit and you don't necessarily want to overfill your pump. On this side of the pump, we have the receptacle which comes from the machine. It gets plugged in like so. Normally the pump is supplied with 2 little filter baskets, an O-ring and spacer. I'll just simulate connecting things up. You'll have to do it on your own, but the intake gets the vacuum hose from the machine. The clamp is slipped over the side. The bolt goes through. The wing nut is tightened down. Till it's very snug. And now you've made a vacuum connection. You do the same thing with the exhaust and oil filter. There's a spacer with an O-ring. Slide the clamp over top. And now the system is plumbed and ready to use. Okay, now everything is set up. You can see the rotary pump on the floor. We give you 1.5 meters of hose, which means that you can conveniently place it below the machine if you have access, or even in a chaseway behind. If you like, you can place the oil pump right next to the instrument. If you do that, it's helpful if you cut the line a little shorter. It's plugged in, so now I will power it up. And the computer will boot up. And now we can open the other box that comes with the system. Okay, I've opened a narrower box which contains all the different inserts and in the chamber sort of accessories that we sort of glanced over at the beginning after removing the restraining plate. This is a TES system, which means that it's capable of both evaporation and sputtering. So in one bag we have our standard stage. I'm not going to open it up and place it because I don't want to unwrap everything. It's really not required. I will show you other inserts that come with this system. This one is the carbon rod evaporation insert, which I made mention of looking at the accessories. These are the springs that you get some spares because as these heat up, they get metal fatigue and need to be replaced. Those are the springs that keep tension on your rods during evaporation. These inserts, no matter which one you have these pins which will tell the computer which insert is installed, and this will allow the system to automatically select the process that matches the insert. Now this is just telling you to remove the restraining plate after shipment. Since this is just a demonstration, I'm not going to actually remove that, but we would want that sort of out of the way. Okay, so the insert drops into the hole in the top of the arm. It's keyed so you get it in correctly. Please also note there's an O-ring here. You need to make sure that this O-ring is kept clean, as well as the edge of the insert, otherwise you'll create a vacuum leak. So we'll just drop this in here. Once the insert is installed, you turn these knobs here and that locks it into place. Then you have to make sure that this silver knob latches with this. There will take a little bit of pushing down on the head to engage the two. This serves two purposes. One, these pins make contact with these switches, identifying which insert is installed. And for evaporation processes, for carbon rod, carbon thread, metal evaporation, these are the high current contacts. So these need to be made for that process to take place. Then you can raise the arm and put your sample in as required. There may be some auxiliary or other evaporation or glow discharge heads involved, but I just showed you how the carbon rod insert gets installed. This is the sputter insert. I'm not going to show you how to install the target. It's quite easy actually. Loosen those 4 hex screws. This rotates and pops off. The target is retained on there by a screwed ring, which is on the outside. You just screw it off, drop the target in, screw it back on, put this back in place, then the whole thing drops in the top of the machine. Now that you've installed either the carbon rod insert or the sputter insert, now your system's ready to run. We will cover the actual operation of the system under another video, but this is enough information to allow you to set the instrument up easily, and if there's any sort of discrepancies, you'll be able to tell us what the discrepancy might be, and we can solve the situation from there. Thanks for your attention.